Hey there guys, welcome to my channel. In today's video, we're going to be solving a nice logarithmic equation where we have log x with base 2 plus log x with base 3 equals 1, and we want to solve for x values. Great, so we're going to do that in two ways, and in the first method, I'm going to go ahead and start with the change of base formula. So we know that log of a with base b can be written as log of a over log of b, right? So let's go ahead and use this on the left-hand side. We're going to have log x over log 2 plus log x over log 3 equals 1. Next, let's go ahead and get a common denominator on the left-hand side. So we're going to have log 2 times log 3 in the bottom. And on the top, we're going to have log 3 times log x plus log 2 times log x. And the whole fraction is equal to 1. Cool. Next, let's go ahead and factor out log x on the top. So we're going to have log x times log 2 plus log 3. And this is divided by log 2 times log 3. And the fraction is equal to 1. Cool. Now, notice that we have a sum of two logs with the same base. So we can turn this into one log and write it as log of the product of the arguments. That is 2 times 3, which is 6. So we have log 6, which means that we have log x times log 6 divided by log 2 times log 3. And this equals 1. Now, in order to isolate log x, we need to multiply both sides by the reciprocal of this fraction. If you do that, we're going to have log x equals log 2 times log 3 divided by log 6. Cool. Now, notice that the basis here is 10, which means that by the definition of logarithm, I can solve for x. And if I do that, we're going to have x equals 10 to the power of log 2 times log 3 divided by log 6. Now, in order to simplify this, let's go ahead and write this as x equals 10 to the power of log 2 raised to the power of log 3 divided by log 6. Now, notice that whenever we have something in the form of a to the power of log b with base a, that is equal to b, right? Now, since we have 10 over here, we can say that this is 2. And notice that by using the change of base formula, we can say that this is log 3 with base 6. So if we simplify this, we have x equals 2 to the power of log 3 with base 6. Cool. So this brings us to the end of the first method. Let's go ahead and take a look at the second method. But before we do that, let me rewrite our equation. So we had log x with base 2 plus log x with base 3 equals 1. Now, in the second method, I'm going to go ahead and use a nice property. So we know that log of a with base b can be written as 1 over log of b with base a, right? So by using that on the left-hand side, we're going to have 1 over log 2 with base x plus 1 over log 3 with base x, and this equals 1. Next, let's go ahead and get a common denominator on the left-hand side. So we're going to have log 2 with base x times log 3 with base x in the bottom. And on the top, we're going to have log 3 with base x plus log 2 with base x, and this equals 1. Again, we have the sum of two logs with the same base, so we can write this as log of 6 with base x, which means that we have log of 6 with base x over log of 2 with base x times log of 3 with base x, and this equals 1. Next, let's go ahead and multiply both sides by log of 2 with base x. So we're going to have log 6 with base x over log 3 with base x equals log 2 with base x. Next, let's go ahead and use the change of base formula backwards on the left-hand side. So we're going to have log of 6 with base 3 equals log of 2 with base x. Next, let's go ahead and flip both sides. So we can write this as log of 3 with base 6 equals log of x with base 2. And then by using the definition of logarithm, we can say that x equals 2 to the power of log 3 with base 6. Cool. So we solved for x in the second method, and we are done with this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.